Alrighty, good morning, guys. It's nice to see you all here on our first day of class. I think we have I think we're just missing a couple of folks, but I am going to go ahead and get started. Welcome to Honors Calculus 1. Today is going to be a pretty straightforward day. I'm going to go over the syllabus. We'll start introducing some of the concepts, but it will not be heavy in calculation. First, let me kind of introduce you to the way class is going to run. So, of course, as always, I'll post a link to the Zoom meeting for our day's class under the announcements, and you will follow that link at the appropriate time to come here. I'll be using the screen share. Listen, bud, you got to pick if you want to be in or out. Sorry, cat scratching at the door. I will be using the screen share feature in Zoom quite a lot, pretty much through the whole class. So let me go ahead and show you what that looks like. It's going to maximize automatically, and I'll ask that you leave it like that so you can see all the text that I'm going to write. Every day I'll begin class. Nova, you got to choose what you want, buddy. All right. So every day I'll begin class like this. With the class number here, this is MAC2311, Calc 1. The section is OH1, if anybody ever asks. Today is a lecture, and the date is the 6th of January, 2021. And then today, we're going to go over the syllabus. We're going to discuss the student teaching, and the honors project, and then we're going to talk a little bit about real numbers, open intervals, and the main concepts from calculus. So after we get all of this kind of bookkeepy stuff out of the way, I'm going to give you a very high level, very basic overview of the primary problems that we're going to be trying to solve this semester. But since this is an honors class, we're going to have to spend some time talking about these special honors components, which are the student teaching and the honors project. So without further ado, I'm going to pop open your syllabus. Let me show you how to get to that. So you all found your way to class here today, which means you are loaded into Canvas, and that's very nice. If you look on the main page of our Canvas class, which is the syllabus page, you'll see a few links. The one I'm going to open up right now is this link for the full course syllabus. I would like everybody to save a copy of the full course syllabus somewhere on their computer. I recommend making a little folder on your desktop for materials from this class. You can save it. I'm not going to actually save this right now because I have a copy of it open elsewhere. Oh, maybe I don't have it open here. Let's title. There we go. All right. So this is the full syllabus that you will download from that link. And again, I'd like everybody to keep a copy of this saved somewhere they can refer back to it, because of course there are a lot of important details in here that you'll need. My name is John Filesticker. I'm an assistant professor here at Santa Fe. I did my undergrad and graduate work at UF, finishing in 2013. My focus was in number theory, analytic number theory specifically. My office on campus is A031D, but you won't find me there much because we're still operating remotely due to COVID. Email is certainly the best way to get a hold of me, and this is my email address. You can click this. It's a link. It's a mail to link, so it will launch your mail client with the email already addressed to me. When you email me, please just include this information, right? Let me know that you're in section OH1 of MAC2311 in the subject line. That will let me set up a filter, which will sort the emails automatically and help me keep things organized, reply to you quickly, all of that good stuff. This phone number here, this rings in my office, so unfortunately it's not a great way to get a hold of me right now, but I do have it set up to forward to my cell phone, but again, that really doesn't work well because I don't have working caller ID with the forwarding, and a lot of those are scams, so I don't tend to answer this phone very much right now. If you need to get a hold of me, just send me an email or a Canvas message. Class meetings are Monday, Wednesday, and Friday from 11 a.m. to 12:15 p.m. here in Zoom, and I'll always post those links in the same place you found the link for today. It'll be in the Canvas announcements. Office hours are Monday, Wednesday, Friday, 1 to 2, and Tuesday, Thursday from 11 to 12. Or if you want to meet outside those times, I'm happy to do it. I do a total of 10 office hours a week, so there's 5 of them scheduled here. The other 5 I leave open for you guys to schedule by appointment. So don't be shy about emailing me and saying you want to meet outside of those times. I'm happy to do it. To come to the regular office hours, you just, during any one of these times, click these links. These are Zoom links, and they will launch Zoom and put you into a waiting room for my office hours Zoom meeting. Of course, if you try to click those links during one of the, not during one of these times, it'll dump you into the waiting room, but it won't do anything. I won't be there. But if it's, Thursday between 11 and 12, click this link. Or if it's Monday, Wednesday, Friday between 1 and 2, click this link, and you'll be dumped into a waiting room for a Zoom meeting just like the one we're in now. The final exam, and everybody, if you could, please put this in your cell phone right now, in your calendar, or wherever you store important dates and times, is April 28th from 10:30 to 12:30. So that's not our normal class meeting time. It's really important that we keep this in mind. The prereq for the honors version of Calc 1 is a B or better in the 2 prerequisite courses or the combined course, and of course a successful interview, which all of you guys had, so congratulations. I'm very happy to have you all here. The textbook for the class is Stewart. Stewart is a very old book. It's a book that's been used since the 70s. We're in the 8th edition now, and we always use the early transcendentals version. Early transcendentals just means we introduce things like the trig functions, e to the x, natural log, all of those very early on. We don't wait until down the road to introduce those functions. If you need it, although I don't think you will, this is the ISBN for that textbook. What you will need, well, you don't necessarily need a hard copy of the text, you will need an access code. The WebAssign access code is very important. So all of the homework for this class is going to be in WebAssign, and you need the access code to get in there. The other thing that you need is the class key. This is what you use to register for our specific class within WebAssign. If you don't have your access code yet, that's okay. You can still go to WebAssign. I'll show you here. There's a link in Canvas. You can just follow this link. And then up here at the top where it says enter class key, you can click that and it'll ask you for our class key. You go ahead and type it in, hit register, and then it will ask you for your access code. If you don't have your access code yet, you're either waiting for it to be mailed to you or you're waiting for your financial aid to drop to get it, or for whatever reason you don't have the access code, that's okay. The page that asks you for your access code, if you look down on the bottom, there's a little link there that says click here to use temporary or trial access. That will get you in for the first 2 weeks of the class, and as long as you get your access code and you enter it before that trial access ends, everything will be fine. So one of the things I'm asking you guys to do, think of it as your first homework assignment, is just to get registered in this WebAssign class today. Right, I would like everybody to get in there today. Even if you don't have your access code, you can get in using the trial access. And the class key you need to register for the class is right here in the syllabus. You can just copy paste it into that box I was showing you a second ago. You will not need a calculator for this class. But if you want one, the only one that's allowed is this one. That's the Texas Instruments 30IIXS or 32XS. That's the only calculator you're allowed to use on tests. But you will not need a calculator, right? I encourage you to forego the calculator altogether. It's not necessary. I promise I won't give you big, crazy arithmetic problems or anything that a calculator would be helpful for on a test. When it comes to evaluating trig functions, like the sine of 5 pi over 6 or whatever, I need exact values. And this calculator will not return those. This will just return a decimal, and that decimal isn't in any way valuable to me. So I need you guys to know your unit circle. That's the only place where a calculator might be tempting to use in this class, and that calculator won't do it. But if you want a calculator to check your arithmetic, or just because it makes you feel a little bit more comfortable to have it if you want it, this is the one you're allowed to use, no others. Specifically, graphing calculators or calculators with CASs, computer algebra systems, capable of symbolic manipulation, those are very much not allowed. So no TI Inspire, no TI 89, or any of that stuff, please. One of the other things you'll need for the class is definitely a computer with a working up-to-date web browser. Specifically, make sure Chrome is up to date, because when we go to do our exams, we will be using HonorLock as part of the proctoring. And HonorLock requires that Chrome be kept updated. If your Chrome is out of date, sometimes that can cause troubles with HonorLock. Another thing you'll need is consistent, reliable internet access. I've lived in a bunch of apartments here in Gainesville. I understand that some of them have not super reliable internet. If you know that the internet at your apartment goes out from time to time for an hour or two, I strongly recommend coming up with an alternate plan. So have somewhere else in mind that you know you could rush to take a test or whatever if your internet were to go down. Some places I would recommend are, of course, Santa Fe's campus. You can always go up there. There's a bunch of places you can just hang out and use the Wi-Fi. Some people have had luck at McDonald's. I think I had someone take a test in a McDonald's parking lot last year. That was interesting. But just have a plan B, right? Make sure you have a plan B if you know your internet goes out sometimes. Another thing you're going to need for sure is a working webcam. You're not required to have your video feed on during class time, so you don't really need a webcam there, but you are required to have that on for the tests. And actually, the way we're going to proctor tests, I'll talk about this when we get down to that portion of the syllabus, is going to require you to have 2 webcams. You're going to use the webcam on your computer, like we're using right now, and you're also going to use the camera on your phone. So one of those will be showing me your face, and the other one will be showing me your desk, right? So I can see your hands, your paper, your pencils, your whole workspace. We'll talk more about that in a second. If you have trouble getting any of these things, either you don't have good internet access, or your computer is an older one and doesn't let you update Chrome, or for whatever reason you don't have a working webcam, or you don't have a phone with a camera on it that we can use for Zoom, just let me know. I can get you a laptop to borrow for the semester. If you need a webcam to set up as a second webcam, or something like that for the exams, just let me know. I can get you that stuff. It's not hard. The course description. So this is the first in the 3 course sequence of calculus classes. And in Calc 1, we focus mainly on the derivative and tangent lines, things like that. But by the end of the semester, we'll also be talking about the area problems, what are called integrals. So it's a pretty broad scope. But at the start of the course, we're going to talk a lot about real numbers and limits. We're going to use limits to define continuity. We all have some idea of what a continuous function is, but in this class, we're going to get a rigorous definition of what a continuous function is. We're going to talk about rates of change, and we'll combine the idea of limits with the idea of an average rate of change to cook up this thing called the derivative. Once we have the derivative as a concept, we're going to come up with a bunch of different ways to calculate derivatives. Those are called differentiation rules or techniques. From there, we're going to talk about things you can do with the derivative, applications of the derivative, and then we'll shift to talking about areas and integrals towards the end of the class. There's actually a really nice list that Santa Fe puts together of all the little topics for this class. And I do recommend taking a look at this a few times through the semester just to make sure you remember what each of these things are and what they mean, and have all the important concepts tied together where they should be. Cell phone policy. This is less important now than it is in an in-person class, but I'll just ask that you please don't use tech in any way that distracts other people. So right now, I'm not worried about anybody sitting in the back on Reddit or Insta or whatever distracting other folks, but this means other things too. Like, please don't paste memes in chat, or if there's a Discord or a GroupMe that you guys decide to set up for this class, please don't be talking back and forth with other folks during lecture there. Everybody who's here wants to be here, wants to learn this stuff, and we should respect each other's time and independence. So please just don't distract other people. Just be nice. And then this is a big thing during the tests. Of course, no smart devices, no phones, no nada used in any way except for the specific way I ask you to do so. So be very, very clear about that. We cannot take calls or send texts or anything like that during a test. Attendance, I'm going to use Zoom logs to take attendance automatically. And I'll actually be recording that every day for the first couple weeks to make sure you're reported as having attended the class for financial aid purposes. I know that your financial aid does not disperse until you're reported as having attended. So please make sure that your name here, and it looks like everybody has done, but please make sure your name in Zoom is the same name that you have on your Santa Fe ID so I can match that up with the attendance logs. There is no attendance component to the class, but of course, if you miss class, that can be really catastrophic. It's very important that you don't miss class. Makeups, I'm really loose about these. If you miss a test, I need some sort of explanation, right? A reasonable documented excuse. Whatever it is, just let me know, and then we can schedule a makeup, but that has to be done within 1 week of the missed test. So if you let a week go by and we haven't done the makeup yet, then we're in trouble, then we can't make that test up. But as long as you talk to me ahead of time or let me know as soon as you can that you are going to miss or have just missed a test, I'm happy to work with you and schedule a makeup exam. If you miss a homework, if there's a homework assignment that is past due or anything like that, don't stress. You can submit an extension request in WebAssign. I don't take off points for that or anything along those lines. You guys are all adults, and I'm inclined to treat you as such. So please just stay in communication with me. If you fall behind or if you miss something, I want to work with you and help you catch back up. I don't think that will be so much an issue in the honors class as it is with others, because I know you guys are all very responsible and very interested in working hard and doing well. But just know that if you communicate with me, I'm happy to work with you on getting old things handed in. The one hard deadline that I have is the day of the final. The final needs to be taken on this day, and I cannot accept any work after the final. So this is the absolute last day I can take any work for grading. Besides the test, there are a couple other big things in this class, namely the homework and the study guides. So every week there's going to be a homework set on WebAssign, and it'll open on the first day of class and then be due the first day of class the following week. So immediately after class ends today, you will see a homework 1 open up in WebAssign, and that will be due at the start of class on Monday of next week. And then at the end of class on Monday of next week, homework 2 will open, and that will be due at the start of class on Monday the following week. So at the end of class on the first day of each week, your homework opens, and it's due at the start of class, the first day of class the following week. So it's not due at midnight on Saturday or anything weird like that. It's due at the start of class on the first day each week. Before each midterm exam, I'm going to publish a special homework assignment called a study guide. You have to solve the study guide problems in WebAssign, but that's not where the study guide grade comes from. The study guide grade comes from you scanning your written work for those problems. Just like you would hand in the written work in class, here online you're going to scan them. I like the app Cam Scanner, but if you have an actual physical scanner, that's even better. But you need to get me legible, readable, clean scans of your work, and to get the grade for the study guide, you will submit that written work to the assignment in Canvas here titled Study Guide, right? So Study Guide 1, this is where you would submit the written work for the problems in the homework assignment titled Study Guide 1. So again, to get credit for the study guides, you have to submit the work. Ideally, you would submit that work before the test, right? You can submit it on the day of the test if you want to, but ideally you would submit it before then so I can look at the work and give you some feedback. I'm going to be going through your study guides and saying, you know, if you did this on an exam, I would take off a half point, or if you left off this symbol here, I would take off a point on a test. The idea there is that I get to see your style. I get to see how you write and use notation, and you get to see my style. You get to see how I grade and the things that I would take off points for before the test. And that way on the test, we have a similar understanding. You know what to expect from me as far as grading is concerned, and I have a better feel for how you write things. So that's the idea behind the study guides. And again, to get credit for those, you have to turn in the written work no later than the day of the exam. Lab meetings, normally the way I run labs are as what are called recitations, where you guys would bring questions from the homework. You know, how do I solve this problem? Or how do I solve homework 5, problem 3? And then somebody else from the class can volunteer a solution. Because of the way we're doing things online right now, it's a little bit hard to do that. Not everybody has a document camera at home that they can use to share their solutions. So labs, for the most part, while we're online like this, will just be extra class days, but they'll be focused on solving problems. So you guys will tell me what homework problems you're struggling with or what sort of things you want to look deeper at. And on lab days, we will dive a little bit deeper into how to solve those problems. There will also be some days where I give you guys little kind of lab assignments, and I'll show you how to work through those. Usually you'll use some sort of computer algebra system like Maple or Derive or Desmos. Desmos has been very popular lately. The tests, there are going to be 3 midterm exams and 1 final exam. So I'll show you on the calendar about where the midterm exams are going to take place, and then the final, of course, is on April 28th. At 10:30 a.m. The way I'm running the tests right now is in Canvas. So I type the questions in the markup language LaTeX, compile them, and then upload them to Canvas in the form of a Canvas quiz. It's all very easy to use. And the proctoring system is HonorLock, but in addition to that, like we talked about a little bit ago, I'm going to require you guys to have your phones signed into Zoom. And then you will set your phone on your desk so that I can see your hands, your paper, your work surface, and actually watch you write. So HonorLock will record your face and your screen and your web traffic. And then on Zoom, I will be able to see your hands, your desk, your writing, and work surface. The tests are all going to be during normal class time. So with the exception of the final, right? The midterms will be during normal class time. And it's not like an online class where you can take the test all day. It has to be during class time. I'll add like 30 minutes on either side, you know, like 30 minutes before and 30 minutes after to help you deal with any technology issues that you have. But it's just like an in-person class in the sense that you have to take the test during class. The final, again, is on April 28th, 10:30 to 12:30, and it's going to be run the exact same way as the midterms. It'll just be a little bit longer. Before I move on to the second page, are there any questions that you guys have on any of these policies or systems? And if you want to, you can hold down spacebar to talk, or you can type in the chat. I see something in chat here. Oh, okay, cool. All right. Kieran's feeling good. Chris is feeling good. All right. If you do have any questions, feel free to interrupt me. I know this stuff is not super exciting. I'm going to go ahead and move to the second page here. So there's a recording notice. I record all of these lectures on my computer, and then once they're processed on the computer, I upload them to YouTube. What that means is if your video feed is on in Zoom, then you will appear in that YouTube video. Now, I don't send them anywhere else or publish them anywhere besides Canvas, so you don't have to worry about rando folks stalking you through YouTube. But if you're nervous about that, if that makes you uncomfortable, especially because your full names are there, feel free to turn off your video feed if you're not comfy having that appear on YouTube down the line. Another thing to note is that HonorLock records your webcam and your screen, and so during tests you want to make sure that you're dressed and make sure there isn't anything crazy lying within view of the camera. All right. That gets us to the honors component of the class, and I did my best to get all the information for this into the syllabus, but we will talk a lot about these throughout the semester. As you guys know from the interview for the honors class, there are 2 main things that you have to do extra for the honors class, and that is an honors project, which is basically like a science fair project, but relating to mathematics, and student teaching. So I'm going to just read through this really quickly for you. Before the end of next week, you guys got to let me know what you want to do your honors project on. The honors project is going to require you to write a little paper, put together a PowerPoint or similar presentation, and make a poster board, like a science fair project poster board, all on that topic. Now, your research paper and your presentation, there will probably be a lot of overlap in the material. Right? The paper can be basically a written explanation of what is in your presentation. The presentation should tell me all that you learned about that topic while you did your research. And then the poster board should be a nice, concise collection of the most important bits of your research, hopefully with some pictures or some diagrams or some graphs, some things to help you explain whatever the topic is that you chose. You're going to be working on this throughout the whole semester, and I'm going to require you guys to meet with me at least 3 times through the term to discuss progress. So by the end of next week, you got to tell me what your topic is. The things you're going to be working on are a paper, a PowerPoint, and a poster board. And you need to meet with me at least 3 times, and I'll set up a schedule for those meetings before the end of next week. At the end of the semester, once you've got all your things, nice and polished, there's going to be a presentation. Normally we do this in the form of like a pizza party. I'll order some pizza and reserve a room on campus, and everybody can come in and give their presentations. I know that right now with COVID, that's not super likely unless we all happen to get vaccinated before the end of the semester. So we may end up doing a Zoom pizza party, something like that. I'll see if I can figure out a way to get you guys all some pizza on that day. But basically, we're all going to get together and just share what we worked on. You're going to give your presentation. That's the purpose of the PowerPoint. You'll give that presentation, explain your board, and you'll hand in your research paper on that day as well. Some things that you want to keep in mind for your presentation are, a little overview of the topic, explain what it is you chose and the basic mathematical tenets thereof. You're going to explain what's been going on in that research area recently. What are the most recent breakthroughs in that area? And then you're going to talk a little bit about where you think that stuff might go in the future. So I know some people talked about physics of roller coasters. Some folks were interested in doing that. You can tell me a little bit about what roller coasters are currently pushing the boundaries of design and what things you think might be done in the future to enhance those boundaries or to push those boundaries further. I think one person is interested in the water physics for the video game series Halo, and how Halo kind of revolutionized the way water physics are done in video games. You can tell me a little bit about how that's moving forwards. I think the Halo series still exists and they're still releasing games. So what are they doing now? How is that mathematics changing? Or how are other video games taking that stuff into consideration, and what effect has it had on the industry as a whole? That sort of thing, right? So the research project should give me a little summary of the area, a meaningful discussion of what research has been done, and then a little discussion of what research might be done in the future. I really would like you guys to enter your projects in the RU Fair. The RUE, or Research Undergraduate Education Fair, is an excellent way to open doors for scholarships. There are a couple scholarships tied to the RU Fair that can get you cash in hand immediately. That's always nice. But it's also a really good way to connect with faculty in town here who are interested in doing research with undergraduates. I have a student, he's not in this class, he took Calc 1 with me last semester, who's working with a number theory professor at UF now after he and I did some work on the di-gamma function. Very cool. He was very interested in that and did a bunch of great work on his own. He's entering it in the RU Fair this semester, and I would be surprised if he didn't earn some scholarship money from that. Another big thing here, the projects, you can work with up to 1 other person. So you can do this entirely on your own if you want to. You can do your own thing, all on your own, that's fine. If you want to, you can work with 1 other person. If you guys both want the same topic, or you're both interested in the same sort of thing and you think you would want the same topic, or if there's someone in class that you just happen to be friends with or you want to get to know and work closely together with, just make sure you choose, if you choose to work with somebody else, make sure you make that selection very carefully. I would not like to see something where one person ends up putting in all the work and the other person ends up feeling left out or unfairly treated, or the converse, of course, that would be bad as well. So you're welcome to do these on your own. You're welcome to do them with 1 other person, but no groups larger than 2 for the honors project. A few topics, and these are just suggestions. You can definitely pick from any one of these if you want to, or you can come up with something else, but a few topics. There are some famous mathematicians you can research. And if there isn't a specific research topic you're interested in, this might be the easier path to go on. So if, for example, you wanted to study Sophie Germain's work, You can look into what she did. She was a very early number theorist, but because she was working in a time when women weren't given a whole lot of credit in mathematics or hard sciences, she had to publish under a pseudonym through somebody else. It was really rough, but she did a bunch of beautiful, beautiful research. You could just tell me about her work, the research areas that her work led to, and the more recent things going on in that research area. And the same could be done for any one of these mathematicians or any other mathematician that you choose. Other things you could do, the physics of roller coasters. This is actually something that our textbook talks about. They have a little research project in the textbook on the physics of roller coasters. It can be found on page 182. And so this is another thing that's kind of laid out for you already. A few other topics that are in the textbook as research projects with some outlines are controlling red blood cell loss during surgery. Why are cans shaped the way they are, right? Like soup cans, why do we use that shape? What's so great about that shape? Why the hell is that what it is? Another cool research project that's in Stewart. You could talk about COVID, right? And the spread of epidemics. Epidemiology is a really hot field. It was before COVID, and it's become much bigger ever since. Or if you want to do something of your own choice, that's fine. But you got to let me know what it is, and I have to approve it. My guidelines for approval here are just that the topic needs to be accessible. It needs to be something you can actually research. Doesn't require like 5 years of graduate work before you can even talk about the thing. Those sort of things are a little tough. And it has to be mathematics, all right? Chemistry is not math. Physics is not math. If you're going to do something that's physics-y related or chemistry related, you have to focus on the mathematics. So if you would like to do a topic that's not listed here, that's fine. Happy to do whatever you want, as long as it is at its heart a mathematics thing. The research you need to discuss needs to be math research, not some other sort of research. Any questions about the honors project, what it is or what you need to do? Comments, concerns, crises? Cool, okay. Again, by the end of next week, I need to know what you're gonna do. All right, so you don't have to give me a whole bunch of stuff, just the topic, but by the end of next week, I need your topics to be sent to me and approved by me. And then you can get started, but please don't get started tearing away on work before your topic has been approved, right? So if you think you know what you wanna do, submit that topic to me, just send it in an email or a Canvas message. Make sure I approve it, and then you can get started. If you want to do one of these, go ahead and take a look in the textbook at these pages and see if you like the outline that's discussed there. If you want to do something else, I can help you research it as well. The other big thing that's required of you for this class that is not required in the non-honors section is a student teaching day. So not every day is going to be me lecturing. In fact, a bunch of the days it's going to be you guys. Here are the sections that I'm okay with you guys teaching. And before the end of the second week, again, before the end of next week, I need you guys to tell me which of these sections you want to teach. You need to look through the textbook and read the section, at least take a look at it, and make sure you have some idea of what the content is in order to make that decision. So if you don't have a copy of the textbook to look at, you can check one out from the library. I can help you get a PDF of the textbook if you would like, or of course, as soon as you're registered in WebAssign, you'll have access to the electronic copy there. But this section 2.3, for example, we'll be covering this like at the start of not next week, but the start of the week after, and maybe even a little bit next week. So if you wanted to do 2.3 or even 2.6, I would need you to let me know very, very soon. Other sections, 3.1, which is like the power rule, if you know anything about calculus from high school or elsewhere, and derivatives of exponential functions. 3.2 is on the product and quotient rules. 3.10 is on linear approximation and differentials. 4.1 is finding mins and maxes. 4.4 is on L'Hopital's rule. If you've ever heard of that, it's a sneaky trick for taking limits. 4.9 on antiderivatives, 5.1 on areas and distances, 5.4 on indefinite integrals and antiderivatives, 6.1 on areas between curves. These are all topics, sections I would be comfortable with you guys teaching. So please pick one of these, or if there is another section that you really want to teach that isn't listed here, again, let me know and I'll take a look. Some of the sections in the textbook I really insist on teaching myself because they're kind of tricky in their concepts and I want to make sure everything is done exactly the way I like to do them. But I'd be willing to make exceptions here, especially if you have strong feelings about it. So keep this in mind, make a note. Before the end of next week, I need from you your honors project topic, just the topic, and the section you want to teach for your student teaching. Now, I'm going to read this really quickly. Once the section has been chosen, you need to read the section of the textbook and prepare your lecture. That means I need written lecture notes. I need to be able to look at your lecture outline and know exactly what it is you're going to do. And then about a week, a few class days before you give that lecture, you and I need to meet up for a rehearsal, right? That can be done during my normal office hours, or we could schedule an extra office hour some other time if that fits better. But we need to rehearse the lecture beforehand. Before to rehearse the lecture. Good, yeah, okay. Now here's some format ideas that I wanted to share for the student teaching. Again, normally I would just have you guys get up in front of the board and do a regular lecture, but we're online right now, so things have to be a little different. You could do a single YouTube video. I don't recommend this because if there's a mistake, you got to go back and redo the whole thing. That kind of sucks. You could make like 4 or 5 little 10-minute YouTube videos, each one discussing one little part of that section. I think that's really the way to go, because if there's a mistake, then you just need to go back and fix that one little bit rather than redoing the whole lecture. It's hard to do 50 minutes or 75 minutes with no mistakes. Or if you want to, you can do the lectures the way I do. You can use a document camera like we're using over here to deliver the lecture live. That's an option, but of course you would need a document camera to work with. I can help you rent one from the college, or you can use the media center there if you'd like to do that. But however you do this, you need to let me know what topic before the end of next week, and then about a week before, you and I need to get together for a rehearsal. It's very, very important we do that. Any questions on the honors project or the student teaching? Hey, Kitty, what are you doing? Yeah, so Katie asked in the chat there, how do we sign up? For both of these, just send me an email or a Canvas message. Send me an email saying, I want to do this for my honors project, or send me an email saying, I want to teach this section for my student teaching. And that'll begin the conversation. I'll be saving all of that information in an Excel file. So if I haven't heard from you by next Friday, I will be bugging you. So please just go ahead and send me whatever you would like to do for each of these as soon as you can. All right, the following days are important for this semester. Of course, classes began on the 5th, but I would make note of this. The last day to add a class is the 7th, which is tomorrow. The last day to drop a class is the 11th, which is next Monday. So if you want to make any changes to your schedule, those need to be done very, very soon. The 18th is Dr. King's birthday. The college will be closed for that. And then we do have spring break this semester. I know there's some rumors about that being canceled, but as far as I know, right now we are still planning to do a normal spring break in the second week of March. The last day to receive a W, if you decide that this class isn't going well or there's just absolute chaos in your life and there's no way that you can get through the class with the grade you need, the last day to withdraw with a W is the 24th of March. And then exactly 1 month later is the last day of class. So our last lecture will occur on or before the 24th of April. The final exam is April 28th from 10:30 to 12:30. And again, I'd like you to put that in your phone with a few warning notifications to make sure that it doesn't go missed. And then by May 4th, you'll see your final grades in East Santa Fe. The grade breakdown is like this, right? So most of it's coming from the exams. There's a cumulative final at the end that's worth almost a quarter of the whole grade. And then I will be replacing your lowest midterm by the final. So if you get a 70 on the final and your lowest midterm is a 60, after you take the final, I will go back and replace that lowest midterm with your grade on the final exam. The breakdown is given here in terms of both percentages and points, however you like to think of it. The homework and web assign is worth 45 points, or about 7% of the total grade. The study guides, there are 3 of them, each worth 25 points for a total of 75 points, 12% of the grade. And again, this study guide grade comes from the scans of your written work, not from completing the assignment and web assign, but this is the scans of your written work for those problems that I grade for that. Each of the midterms is worth 100 points. There's 3 of them for a total of 300 points there, and cumulatively those are worth 48% of the grade. The final exam is worth 1.5 midterms, so on its own it's worth 24% of the grade. The honors project itself, which is the combination of the research paper, the presentation, and the poster board, altogether worth 50 points, which is about 8% of the grade. And then the student teaching is not worth a whole lot. It's just worth 5 points, and pretty much everybody gets 5 points on this as long as they do everything that they're supposed to do, meaning you come to the rehearsal and you contribute fairly to the student teaching. Oh, I think I forgot to mention. So the student teaching you can also do in pairs if you want to, right? If you want to work with someone else on the student teaching, you can do that just like the honors project, but no more than 2 people. All right, any questions about the grade breakdown? Okay. The grade scale we use is the normal one. 90 to 100 is an A, 80 to 89 is a B, and so on, with the top 3 percentage points of each designation earning the plus. So anything 87 to 90 is a B, B plus, sorry. This next page is kind of boilerplate syllabus stuff. The GELO, General Education Learning Outcome, is something that the college tracks. We used to do it on the final. I think I am probably still going to do this on the final exam, but there will be a question or 2 on the final that has a little G next to it. That means it's a GELO question. It's not something that has any effect on your grade. It doesn't go on your transcript. It's just a way for the college to track how well faculty are doing. So don't stress about it, but if you'd like to read more about what those statistics are and why we track them, you can see that at this link. Academic integrity, this is a big deal. Clear, responsible rules regarding academic integrity are strictly enforced for your benefit. This is the only way to keep your degrees valuable, right? If we let people cheat, then your degree doesn't mean anything. So please don't cheat. It's your responsibility to read and abide by the student code conduct. So please take the time to read this link. This is important. I know it's 23 pages and it's not fun reading, but it's really important that you know these rules, because these are the rules that you are being held to in this class. And especially lately with COVID and everything moving online, there's been a lot of problems with academic integrity. I'm going to talk more about that in just a second. The ADA, if you have any sort of disability, if you're registered with the DRC, or you think you might be entitled to any sort of testing accommodations, just let me know. I'm happy to work with you. The DRC folks are really great. They're super friendly and super helpful, but sometimes they're a little bit slow in getting paperwork done. So if you think you are eligible for some testing accommodations, whether that's a specific environment or extra time on tests or a note taker for the class or anything like that, let me know. Independent of your work with the DRC, please let me know. And especially if they're dragging their feet on getting things done, I will just go around them and do those things for you anyway. That way we don't have to worry about it and everybody gets the accommodations they deserve. Accessibility. So I create all the documents for this class using the markup language LaTeX, and I publish them as PDFs, which work great with screen readers and all those neat resources for people who are hard of hearing or hard of vision or anything like that. If you have any accessibility related concerns, either trouble accessing or getting those tools to work with the documents from class, or you know, you have problems getting the technology you need, like a webcam or laptop or anything like that, just let me know, and I'm more than happy to help you get those things. The college does have a laptop loaner program right now, which is really nice. For free, you can borrow a laptop for the whole semester. You just got to let me know, and we can get that set up for you. And the same goes for any other tech that you need. Discrimination and harassment is fairly self-explanatory. Everybody who is here deserves to be here and deserves to get the most out of this class. So please be kind to each other, respect each other, and show that same kindness and respect to everybody involved with the college, faculty, staff, other students. Just be nice to each other, right? Make sure that we're being inclusive and friendly with everybody we deal with in the class. Student rights and responsibility. This is somewhat similar to the academic integrity thing above. Here is a list of rules that you are being held to at Santa Fe. So some of these things are to protect you from the college or from other people, and some of these things are to do the exact opposite, to protect the college and other people on campus from you. So you should know what these are. You should be pretty aware of what the college expects of you as far as conduct and behavior are concerned. And you should also know what you have the right to expect from the college and from faculty. So I would strongly suggest taking a look at that. Down here I have an extra note on cheating, and since this is an honors class, I'm not especially worried about it, but I do want to take a second and talk about this. Just from one of my classes last semester, and just from one of the exams, the final exam on my Calc 2 class last semester, I had to fry 9 kids for cheating. And cheating has taken a lot of different forms in the COVID land. You know, there's so many ways to get around honor lock. There's so many ways to look things up on Bartleby or Photomath or Wolfram or Quora or Stack Exchange. There's a million different ways to cheat. And I just want to let you know that I'm familiar with all of them. I know what they look like. And even if you think you're disguising something in a way that will make it opaque, it's probably not the case. Not all professors have been as strict as they should have been over these last few semesters, and I think that's because of COVID. There's a lot of sympathy and a lot of compassion for people who are struggling. So here's the deal: if you think you're going to be tempted to cheat on a test for whatever reason, things in your life aren't going the way you want them to, or you haven't had the time to study the way you needed to, if you think for any reason you might use Photomath or Wolfram or Bartleby or anything like that on a test, instead of doing that, reach out to me. Let me know that you're feeling that pressure. Let me know that you're in a situation where you're having a hard time making the right decision, and I will do everything I can to work with you. I will move exam dates around. I'll get you private tutoring. I'll work with you one-on-one myself. I can extend the length of the class even through incompletes. I will bend over backwards to help you succeed in this class, but I need you to be honest with me. And if I do catch something that's not kosher, even if I just suspect something that's not kosher, I will not hesitate to file an academic conduct complaint and just let the conduct board sort it out. It's not a pleasant thing for anybody. I hate doing it. But like I said, I had to do it for 9 kids in one class last semester. It was really bad. I don't want anything like that to happen. This is also why I'm introducing the requirement of having the phone up on Zoom during the tests. So we'll be using Honor Lock, and then we'll also have the phone filming your desk and your hands and everything during the tests for Zoom, through Zoom. And I may pop in on Zoom and ask you a few questions from time to time during the test. You know, just how are things going? Which problem are you working on? Can you show me your work? That sort of stuff. But please, please, please don't cheat. If you feel tempted to cheat, do this instead. Just send me an email saying there's no way I can succeed on this test on that day. What are my options? And I will come up with a few options for you. And I'll work with you to make sure things go well. So please just talk to me, right? Communicate with me, and I promise I'll be fair and understanding. Here's an outline for the course. It's very, very, very approximate. Things are likely to move around, but these are approximately the sections of the textbook we're going to cover in each week. So this week we're starting on a Wednesday, so some of this isn't going to make it in, but we're going to talk a little bit about tangents and velocities. We're going to talk a little bit about limits. We're going to do a little bit of algebra review, but not much because this is an honors class. And then next week we're going to address limits. We're going to look at limits both from an intuitive standpoint, and we're also going to look at them from a rigorous standpoint. That's the extra section 2.4 of the textbook that we cover in this class. We'll talk about continuity. We'll define exactly what it means for a function to be continuous at a point. And then we'll talk about limits at infinity. From there, we move on to develop the derivative and then differentiation rules. We'll talk about how to find derivatives of trig functions. And we'll talk about the chain rule. And by that time, we'll be ready for exam 1. So you can expect exam 1 to be somewhere around week 5, probably the first, maybe the second week of February, depending on how much time we need in here. After that, we're going to start talking about applications of the derivative. So how to differentiate implicitly, that is finding derivatives of functions where you can't necessarily solve for y to get started. And we're going to talk about taking logarithmic derivatives, where you take the natural log of a function before you differentiate it, which is a very cool little trick. And then we'll talk about related rates. These are physics problems that we can solve using calculus. Linear approximation, for example, how does your calculator know the decimal expansion for the square root of 2? I'll be showing you, it's really cool. And things like min-max problems, right? How do you find the local minima and local maxima for a function without the graph, right? Without having a picture telling you, you can point at it. How do you actually find those things algebraically or numerically? From there, we're going to talk about graphs. We'll do lots of graphing by hand in this class. Graphs of functions are the main thing in this class. We'll talk about L'Hopital's rule. L'Hopital is actually a guy who stole a theorem from someone else and then named it after himself, but it's a cool theorem. We're going to talk about it. And we'll talk about curve sketching, how to draw graphs by hand really, really well using information from the first and second derivative. Then some more physics problems and exam 2. Spring break right now is scheduled for the 10th week, which is the second week of March. And then we're going to come back and start talking about integrals and areas. So this is kind of the second chunk of the class where we change from talking about tangents and derivatives and start talking about areas and integrals. FTC stands for Fundamental Theorem of Calculus. There's 2 parts of it, and this is what connects the area problem to the tangent problem. And I'll describe what I mean by those in just a minute. From there, we'll talk a little bit about applications of the integral, what differentials are and differential forms. We'll talk about the mean value theorem, and then I'll show you a few tricky ways to evaluate integrals before the end of the semester. But that's a rough outline of the topics of the course. Again, you can go up to the very top here, look at the official course objectives to get a more detailed list. But that's about it. So any syllabus questions before we get moving? Okay, so then I'd like to come over here and start sort of introducing the concepts of calculus. There's a few sort of high-level topics that I want to get into your heads before we start working with the nuts and bolts stuff, because it's very easy to get lost in the nuts and bolts. By the way, anything I write here should go into your notes. That's a good guideline. Anything you see on the document camera is something you should be putting into your notes, unless I specifically say, don't write this down. But here we go. So in calculus, we are primarily concerned with 2 problems. The first of those problems is called the tangent line. This is AKA velocity. So if you're familiar with the term velocity from physics, that is intimately related to the concept of a tangent line. And I'm just going to draw a picture here to show you what a tangent line is. and kind of get you primed for the idea of a tangent line. So I have maybe here the graph of some function, f of x. Here's my x-axis. Here's my y-axis. Whoop, my pen wasn't working, was it? All right. If you think of this graph as being like a ski slope, right, like a hill, and you've got some tiny little guy skiing along it, then if you're going uphill, his skis would be pointing up. If you're going downhill, his skis would be pointing down. And if you look at any particular x value, any particular place along that horizontal axis, and you come in here and you draw the line that his skis would be pointing along, that line is called the tangent line. So I'm going to add the tangent line here in pencil. Since we're looking along the graph of f of x at the x value a, the y value over here would be f of a. So this point is a comma f of a. And this line right here, we call this the tangent line to the function f of x at x equals a. And you can kind of imagine this guy skiing along the hill, his skis moving, moving, moving. At that moment, he would be going downhill like that. And as he continues, I would do something like this. Just for fun over here, I'm going to draw another tangent line. So we'll call this x value down here b. And if we look at the point on the graph up here, this would be the point b comma f of b. And the tangent line there would look like this. Okay, so one of the two main problems we try to solve in calculus is the problem of finding tangent lines. If I give you the purple function, can you find for me the equation of one of these pencil lines? And if I tell you here's the function f of x, and here's some number a in the domain of f, can you find for me this line? Or can you find for me this line? Obviously, what the tangent line looks like depends on where you are. Right? It depends on the x value you're using. Over here, the tangent line is pointing up. Over here, the tangent line is pointing down. And you can start to kind of think about some connections between the behavior of f and the behavior of the tangent line. If f is increasing like this, you're going uphill. F is decreasing like this, you're going downhill. And you can kind of see here, this tangent line pointing down is definitely connected to the fact that f is decreasing there. Similarly, over here, f is increasing, and the fact that this tangent line is pointing up is clearly connected to that in some important way. Tangents turn out to be a limiting case of average rates of change. You remember thinking about secant lines in your pre-calculus class, the slope of a line connecting 2 points on a graph, that being an average rate of change, or the slope of that line being an average rate of change. These guys are instantaneous rates of change. We'll talk a lot more about that later, but one of the other things I'd like you to think about besides pointing down and decreasing or pointing up and increasing is what happens at the top of this hill, or what happens at the bottom of this valley. What would those tangent lines look like? You don't have to answer, just a question for you to think about. The other main problem that we attack in calculus is the problem of areas. Areas bounded by curves. So again, if I have some function f of x, I would like to know between two numbers a and b on the horizontal axis, can we find the exact area bounded by that function and the x-axis? So these are the two main questions we try to solve in calculus, right? We try to answer the question, how do you find the tangent line to a curve at any given point? This turns out to be connected to the concept of a derivative. How do I find the area bounded by a curve over any given interval? Turns out to be connected to something called the antiderivative. So up here, I'm going to just add in by tangent lines. This is related to something called the derivative of f of x. And areas, this thing down here is related to something called the antiderivative of f of x. So while they might seem like totally different things, it turns out that through this calculus operation called differentiation, or the derivative, they're really intimately related. And the thing that connects the two of them is called the fundamental theorem of calculus. I've got an alarm going off in my other room. I'm going to go turn that off for a second. I'll be right back. Okay, so in very broad terms, these are the problems that calculus aims to solve. The problem of finding tangents and the problem of finding areas. And they're both really intimately connected to a lot of things in physics and a bunch of other applications. The tangent line problem is connected to the concept of velocity from physics. How fast are you going at any given time? If f of x is your position along a straight track, like how far are you from your starting point at a given time, then the tangent line tells you your velocity at any given time. And conversely, if f of x is your velocity function, tells you how fast you're going at any given time, then the area bounded by that function and the horizontal axis tells you how far you've traveled. So there's a really neat connection to physics in both of these. And it turns out that one is the opposite of the other in terms of this new calculus operation called differentiation. Both derivatives and antiderivatives are described or defined in terms of what are called limits. And the calculation of limits can be a little bit tricky. Algebraically. So to get started in this class, we first need to define what a limit is. It turns out both the derivative and the antiderivative are defined in terms of this new operation or operator called a limit operator. There's an intuitive way to understand limits that's all about graphs. And then there's some very strict ways to understand limits in terms of algebra. We are going to go all the way in this class to talking about the delta epsilon definition of a limit, which is purely algebraic and just involves inequalities. But the calculation of limits in general requires a lot of factoring and a lot of canceling and a lot of dealing with fractions very, very carefully. So the main skills that we need to be concerned about coming into this first week of class are reading graphs and understanding what graphs of functions tell us, and also getting really comfortable factoring and canceling and dealing with fractions. Specifically that last bit, dealing with fractions, is a very important thing. Now, I don't think I have a whole lot of time left to get into the nitty-gritty here. What's this class? This is 11 to 12:15, right? We got about 10 minutes. So in the last 10 minutes, I'm going to give us a little primer on limits. Maybe, yeah, let's call this a primer. Some people pronounce it primer on limits. Specifically, we're going to talk about the topology of real numbers. Topology is the field of mathematics that has to do with the shape of things. But when we're looking at real numbers, what that really means is we're talking about intervals. Open intervals and closed intervals. If A is less than B, then we define the open interval from A to B, which is denoted by these parentheses A, comma B, close parentheses. Sorry, that's a D, denoted, as the set of all numbers x satisfying the inequality A is strictly less than x is strictly less than B. Closed intervals are less interesting. Open intervals are really the knees of the B. So I'm just going to focus on these for now. For example, and anytime I want to write an example in this class, you'll see me do this. I'll write EG off to the left, which is a Latin abbreviation, just means for example. For example, the open interval 0 to 1 is all numbers x satisfying 0 is less than x is less than 1. And I love to ask my college algebra students, how many numbers are in this open interval from 0 to 1? And many of them will tell me none. There's 0 numbers in there, right? 0's not in there because, you know, x needs to be bigger than 0. And 1's not in there because x needs to be less than 1. So there aren't any numbers in there. Is that correct or not? I see Chris shaking his head no. That's good. Why is that not correct, Chris? Maybe try holding down your spacebar if you're speaking out loud.
There are decimals in between there.
Yeah, there's all sorts of decimal numbers in there, right? This interval, so for example, 1/2 or 0.1 or 0.9 or 0.99 or 0.999 or 0.9999. These and so on are all elements of the open interval 0 to 1. So how many numbers are there in this interval?
Infinitely many.
Infinitely many. Good, right? You could construct an infinite chain like this that are all in there. And those are getting closer and closer and closer to 1. Or you could construct an infinite chain like 1/2, 1/3, 1/4, 1/5, 1/6. Or you could construct the chain 0.1, 0.01, 0.001. There's lots and lots of ways to list numbers that are a part of this interval. So there are indeed infinitely many numbers in there. There's certainly more than one, more than two, infinitely many numbers between 0 and 1. And a neat fact about the real numbers is that between any two different real numbers, no matter how close they are to each other, there's infinitely many real numbers in between. It's called density. This is a way of describing the real numbers as being dense. Specifically, the interval 0 to 1 containing infinitely many numbers is a fun thing to think of. And specifically this chain here, 0.9, 0.99, 0.999, 0.9999. If we think about this chain of numbers, they're all pretty close to 1. And as you add more 9s, they get closer and closer and closer to 1. But is 1 itself an element of that set?
No.
Yeah, beautiful. I couldn't see who that came from. Is that Haley?
Yeah.
Beautiful. Yeah, no, 1 is not in there. So is there a largest number in that set? Is there a biggest number in 0, 1, in the open interval from 0 to 1?
No.
Ah, good. Was that Haley?
No, it's Ben.
Oh, Ben, I'm sorry. Ben, can you explain a little bit, why isn't there a largest element of that interval?
Because there are infinitely many numbers, so there's not one biggest number. The 0.99 repetition just keeps on going.
Good, especially that last thing, right? We can always go further and further in this list to find a number that's bigger than any given number, but still in that set. So no matter where you are, you can always zoom in. You know, over here is 0, over here is 1, and we think maybe this is the biggest. Maybe this guy right here. But then if we zoom in, if we take this little region here and we zoom in, we'll find that there's actually infinitely many numbers between that possible biggest and 1 itself, right? Just in this little gap here, there's another infinity of numbers, because between any two numbers on the real line, there's infinitely many more. So indeed, there is no largest element. But this raises an interesting question. So 1 is definitely not in this set. It's too big, right? It doesn't fit the definition. And there is no largest number in this set. So we can always sneak over a little further. We can always sneak over a little further. We can always sneak over a little bit further. This is intimately connected to what's called the least upper bound principle. It's true that 1 is the least upper bound of the set of numbers in the open interval from 0 to 1. But it's not an element of that set. And limits are all based around this concept of least upper bounds, or trying to sneak up on the largest thing that's in this set that isn't in this set, right? Trying to sneak up on this upper bound while staying within the open interval. When we start talking about limits in detail next time, what we're going to be focusing on is this process of sneaking up on some number. And we're going to think about that by restricting the domain of a function to an open interval. And we'll ask, what do the outputs for that function do as we sneak up towards the right endpoint of the open interval to which we restrict the domain? We'll be doing that, and as we do that, tracking what the y values, the outputs from that function, do. It's a pretty sneaky and challenging thing to conceptualize, but I would like for you guys to spend a little bit of time just thinking about open intervals and what it means to say that there's infinitely many numbers between any two real numbers. It's a slightly subtle and slightly complicated thing. The other thing I would like you guys to do is to spend a little bit of time just reviewing concepts like domain and range, reviewing things like factoring, reviewing the definitions of trig functions. So I'm going to go ahead and open up a homework set right after class today, and it's going to have a handful of things in it. It's going to have a few like true-false questions about domains and ranges. It's going to have a handful of little kind of basic algebra and trig questions, and then it's also going to have some stuff on limits. I would like for everybody to get into WebAssign. Make sure you get registered, whether you have to use the temporary trial access or you already have your access code, it doesn't matter, but please get in there and take a look at that homework assignment and try to answer those first few basic true-false questions about trig functions and domains and ranges. Next time, we're going to explore this in a lot more detail. We're going to look at restricting the domain of a function to an open interval and asking what is the largest output from that function as we sneak up on the right endpoint of that open interval that is the domain. And that's how we're going to start talking about limits. That's all I have for you guys today. Are there any questions you have for me or anything you would like to talk about before we conclude the class? All right, so please get into WebAssign and please start thinking about what section you want to student teach and what you want to do for your honors project. You can look in the syllabus for some of those suggestions, but remember, of course, you can come up with your own idea. And I need those things. They will be set in stone by the end of next week. So by next Friday, I need you guys to have all messaged me both the section you want to student teach and the topic you'll be doing for your honors project. Remember, I need to approve those before you can get working on them. So the sooner you send it to me, the better off we'll all be. Let me see. I got a few little questions and comments in chat here. And of course, yeah, Katie, yes, this is how I will be doing the notes through the whole semester. So I use the document camera here, just like I would use a board, a whiteboard or a blackboard in class. And anything I write on the document camera, you guys should put into your notes. Any other questions or comments? Alrighty then, I'm going to go ahead and end the meeting here for today. Thank you guys so much for showing up, and I will see everybody on Friday. I hope you have a lovely rest of your afternoon.
Thank you.